So in this example, we have a hypothesis that we need to test. We have a report that the mean price of a gallon of regular gasoline in the city of Los Angeles in July 2019 was $4.07. Okay, so here's our first statement, our hypothesis, and that is that the mean price is equal to $4.07. All right, we have some sample data to look at here. A sample was taken of 50 gas stations. The average for that sample, so a sample mean is X bar, is $4.02. And we have an overall standard deviation, not for the sample, but in general. So this is a value of sigma at 15 cents. An economist is interested in determining whether the mean price is actually less than $4.07. So here's a second hypothesis, which states that the mean is less than $4.07. Perform a hypothesis test at the 0.05 level of significance. So we know that our first step here needs to be identifying the null and the alternate hypothesis. The null hypothesis always contains a statement of equality. So here we're going to put the hypothesis that mu is equal to 4.07. The alternate hypothesis, H1, in this case, is going to look at the hypothesis that states the mean is less than $4.07. Based on this alternate hypothesis right here, containing less than, I can go ahead and state that this is a left-tailed alternate hypothesis. Now, to run this test, what I'm going to need to do next is I'm going to need to calculate my test statistic. Okay, in the test statistic calculation, we're going to compare the value in our hypothesis, 4.07, to the actual sample mean, 4.02. Obviously, the sample mean is a little bit smaller than the population mean, but we're trying to determine if that is statistically significant in terms of that population mean. So our test statistic here is a basic z-score formula. We're going to take the sample mean, subtract the value of mu in our null hypothesis, and divide by sigma over the square root of n, because that is the standard error for a sample mean. So sample mean X bar is 4.02. The value of mu in our hypothesis is 4.07. Sigma, the overall standard deviation, is 0.15. And I'm going to divide this by the square root of my sample size, which is 50. I'm going to carefully calculate that test statistic here. And I'm going to round my value to 2 decimal places. So I get a test statistic here of negative 2.36. That's telling me that even though this doesn't seem like a huge difference, 4.07 to 4.02, when you take into account the sample size and the standard deviation, which is small here, we're actually looking at a difference that is a little over 2 standard deviations. To determine whether that is enough to be considered statistically significant, we're going to compare this to what we call the critical region. For the critical region, we're going to look at a shaded region underneath our standard normal curve. So here's my standard normal curve centered at 0. I set up here that this was a left-tailed alternate hypothesis. That tells me that I'm going to shade my critical region in the left tail of this curve. The value that I need to find the cutoff point here is the level of significance. And the level of significance for this test is specified at 0.05. That's actually the area of the critical region. So what I'm going to do here is I'm going to go up to my common levels of significance. In this case, we have a left-tailed test with a level of significance at 0.05. And that's going to correspond to a critical value of negative 1.645. So the critical region is what I have shaded. This value that I just found using the level of significance is actually called the critical value for the hypothesis test. Once I have my test statistic and my critical region, I'm going to make my decision. My decision is either to reject the null hypothesis or to not reject the null hypothesis. Those are my only two choices. And I make the decision by looking to see if my test statistic falls within the critical region. Negative 2.36 is definitely less than negative 1.645. It's more negative, so it's somewhere down here. What's important about that is that my test statistic falls inside the shaded critical region. And when that happens, our decision is to reject the null hypothesis. If our test statistic had fallen in the unshaded region, if it had been, say, -1, then we would have said fail to reject the null hypothesis. And then the last thing I'm going to do here is just interpret that decision. Remember, if you reject the null hypothesis, it means you are proving that the alternate is true. So because I was able to reject the null hypothesis, I'm going to state there is enough evidence to conclude, and what's in my alternate hypothesis is that the mean price is less than $4.07. These are going to be the basic steps in every hypothesis test that you do. Null and alternate, figure out left, right, two-tailed, calculate the test statistic, compare it to a critical region and a critical value, reject or fail to reject the null hypothesis, and then state whether or not you have enough evidence to prove, to support what you have in your alternate hypothesis.